Well, for many centuries now, we have kept time using the Earth's rotation as the basic reference. We look at the sun moving across the sky and use that as the main reference for keeping time. And we have adjusted our clocks to keep them in step with the sun. But we know, though, the Earth doesn't rotate smoothly. It speeds up and slows down unpredictably. And these changes are caused by movements in the Earth's core that we can't predict very far ahead, and by changes in the Earth's atmosphere. And as a result, our atomic clocks are now about 1 million times better at timekeeping than the Earth itself. And as a result, we have a very precise timescale based on atomic clocks, but that timescale is not linked directly to the Earth's rotation. And to maintain that link, to keep atomic time in step with the Earth, we put what are called leap seconds, 1 second steps, into the atomic timescale. There are many applications today that do depend on precise timekeeping. For example, telecommunications use atomic clocks to keep the networks around the world, the communication networks around the world, synchronized precisely together. And satellite navigation, our sat-navs in the cars or at home, depend on signals being sent out from atomic clocks on board satellites. Leap seconds are 1 second steps that we put into the atomic timescale so that the atomic timescale and time based on the Earth's rotation remain closely aligned. The last leap second was at the end of 2008. Typically they occur every 2 or 3 years, but since the process of introducing leap seconds was introduced in 1972, we've actually had 24 leap seconds. And recently the rate of leap seconds has actually slowed down because the Earth has been speeding up over the last few decades. But the long-term trend is for the Earth's rotation to gradually decrease, to slow down due to tidal friction. Leap seconds can cause problems because precise timing systems like to have always the same number of seconds in every minute, and adding 1 extra second to a minute every few years is an unpredictable event that systems have difficulty coping with. And if they get a leap second wrong, that can cause loss of synchronization in communications networks or banking systems or whatever, with many unforeseen consequences that can take a lot of effort to resolve. Without leap seconds, our civil time, based on the atomic clocks, will slowly diverge away from time based on the Earth's rotation by an ever increasing amount. And without leap seconds, it's very hard to correct that divergence. Without a correction, eventually our clocks would show the middle of the day occurring at night. So we have to have some means of making a correction, but at the moment no one knows how that's going to be done. It'll take perhaps 40 or 50 years for our civil time based on the atomic clocks to diverge from the Earth's rotation by 1 minute, and around several hundred years for the difference to accumulate to 1 hour. But of course, some systems are concerned by much smaller steps than that. For example, if you're pointing a telescope at an object in the sky, then even a 1 second difference is significant. Well, in theory, we could put a step of any size into the atomic timescale to bring it back into line with the Earth's rotation, for example, a leap minute or a leap hour. But in practice, making a step bigger just increases the difficulties, and of course the precise timing systems around the world have no way to implement these bigger steps. So in practice it's very likely there will ever be any steps in the atomic timescale other than leap seconds. So people are looking at other ways that they could correct the increasing divergence between our clocks and the Earth's rotation. And perhaps the best approach would simply be for countries to decide to change their time zone when the difference becomes too large. Well, NPL is the Centre for Precise Timekeeping in the UK. We have a group of atomic clocks here that form the UK's national timescale. We use those clocks to provide precise timing to companies in the UK, and we also broadcast a radio signal that can be picked up by radio control clocks and set to the UK's time. We also contribute our clock measurements to an international organisation based in Paris, the International Bureau of Weights and Measures, who collect measurements from around 70 timing centres around the world and average all of those measurements to generate the International Timescale, Coordinated Universal Time, or UTC. A number of countries have been arguing for several years now that leap seconds should be ended because they're just too difficult to deal with. Other countries have opposed that. They believe that the consequences of ending leap seconds and breaking the link to the Earth's rotation are much more serious than the problems caused by leap seconds. And the UK has held that position. And the issue is now going to go to an international meeting in January 2012, where a formal decision will be taken as to whether we should keep leap seconds or not.